This is problem 37. Two rockets start from rest at the same elevation. Rocket A accelerates at 20 meters per second squared for 12 seconds and then maintains a constant speed, so the acceleration would be equal to 0 if it's maintaining a constant speed. Rocket B accelerates at 15 meters per second squared until reaching a constant speed of 150 meters per second. Construct the acceleration versus time, velocity versus time, and position versus time graphs for each rocket until t is equal to 20 seconds. What is the distance between the rockets when t is equal to 20 seconds? Okay, so we're going to start with the acceleration graph, and we can integrate that to get the velocity graph and integrate that to get the position graph. So let's say this is for rocket A, this is for rocket B. So this is acceleration versus time, and rocket A accelerates at 20 meters per second squared until we get to 12 seconds, and then the acceleration is 0. So it's 20, constant acceleration, and then 0. Rocket B has an acceleration of 15 meters per second squared until we reach a constant speed of 150 meters per second. It's a constant speed, so I guess once it reaches it, the acceleration would be 0. That would make it constant speed. But I don't know what the time is, so I'm just going to call this time 2 for rocket B, and then later I'll have to figure out what that is. And afterwards the acceleration is 0. Okay, so now integrating that will give me velocity versus time. Or I could do it this way. What would the velocity versus time graph need to be so that we get this acceleration graph? So positive slope would give you this acceleration here, and okay, a positive slope of 20. And then if the acceleration is 0, that means the slope is 0. Here we should have a slope of 15 and then a slope of 0. I'm going to worry about the numbers later and go ahead and draw the position versus time graphs now. Okay, so if the velocity is linear, the position versus time is quadratic. I was told the rockets start at rest, so the velocity I said was 0 there for that reason. They're starting from the same height, so let's say that height is 0. So I have a quadratic equation here. If I draw the graph like this, the slope is 0 here. It's increasing, becoming more positive, so that would give me this velocity versus time graph. And then here it would look similar, but the slope is 15 meters per second. So then here, when we take the derivative of the position versus time graph, we should get this. I don't know what that velocity is, but whatever that velocity is, that's what the slope should be. And it should just continue. That looks kind of steep, but it should just continue wherever it left off. So something like this. I don't want to have to include any numbers with my graphs, but I do have to answer the question about, oh, it said until 20 seconds, so maybe we should just say this is 12, this is 12, that's 20, 20, 20. Oh, well, that's not 12. I don't know what that is. It's 2 TB. T2B. Okay, so I want to figure out what is the difference between the position of rocket A and the position of rocket B. Well, I know that the area under the velocity versus time graph, it's not the position, it's the change in position, but fortunately, we said the rocket started at 0, and actually it doesn't matter because as long as they start at the same height, it will work out. Okay, so I want to find the area underneath the graph here. I have a right triangle here and a rectangle here. Actually, let's start off looking at rocket B because this one's actually going to be easier because I know this velocity is 150. So this area here is 150 times 1/2 times, oh, but I don't know what that is. So that's still going to be a problem. And then this area here would be 150 times 20 minus T2B. Okay, well, let's figure out what the time is. So, what is this area here? The area underneath the acceleration versus time graph is the change in velocity. So this change in velocity should be equal to 150 meters per second because we started at 0, we ended at 150. And that is equal to the base times the height. The height is 15 meters per second squared. The base is our unknown time, which we would like to find. So that time is equal to 150 divided by 15. That is 10 seconds. So we can put that in here. I'm just going to draw this down here. Okay. Our area, which is the change in position, is 1/2 times 150 times 10 plus 150 times, this is going to be 20 minus 10, so from here to here, that's 10 seconds. Which is 750 plus 1500, which is 2,250 meters. This is position B at 20 seconds. For rocket A, we want to know what this velocity is. So that is that area, which is 20 times 12. So that gives us 240 meters per second for the constant velocity that the rocket reaches at 12 seconds. So this area here is going to be 1/2 times the height, which is 240, times the time, which is 12. Let's write that down here. The area is equal to 1/2 times 240 times 12 plus from here to here, that'd be 20 minus 12, that's 8 seconds, times 240, so this area is 8 times 240. And that is 1,440 plus 1,920, which is 3,360 meters. That's the position of rocket A at 20 seconds. They asked us to find what? What is the distance between the two rockets? So that would be 3,360 meters minus 2,250 meters, which is 1,110 meters, or 1.11 kilometers, with rocket A being higher than rocket B. And that concludes problem 37.